Hey y'all, Miss Harper here. I am going to introduce you guys into one last rule here. Now in class we took these notes on our own paper, so you'll have to be writing this down somewhere. And our newest and latest and last rule is called the negative exponent rule. Alright, and our rule here is that we are not allowed to have negative exponents. So your rule officially, like on your star chart, it's going to say x to the negative a is equal to 1 over x to the positive a. Now another way to do this is if we kind of had the opposite. If we had x to the negative a down here, then we would move it upstairs and it would become positive. So this looks kind of confusing, but basically what it means is if you end up with a negative exponent, you're just going to kick him downstairs into a denominator and then he will become positive. Or vice versa. If he's negative downstairs in the denominator, kick him upstairs and he is going to be positive in the numerator. Alright, so let's try to understand why this is the way it is. So let's think. Well, if I have x squared, what does that actually mean? Well, that means x times x, right? Now imagine if I said, what is x to the negative second power? How could we write something negative 2 times? Alright, it's kind of like asking, what is the length of something that's negative 6 inches? Well, you can't really figure out something, you can't have a negative length. And same thing here, I can't write something negative 2 times. So instead what we do is we put it into the denominator where he becomes positive, and this would end up being 1 over x, okay? Or just 1 over x squared. Just wanted to give you guys a visual breakdown of what's happening. So let's check out an example of what you might see. So for example, something like this, x to the third power over x to the 6th power. Alright, now our rule says to subtract these things, okay? So you might think, okay, well I'm going to subtract these up to the top. So this is how you might do it. And then you'd be like, uh-oh, I have x to the negative third power. Alright, so then you would just have to take it a step further and say, okay, well he's negative, so that means he needs to go downstairs into a denominator. 1 over x to the positive 3. Let's understand why this is happening. X to the third power. That's x times x times x over the 6th power. 1, 2, 3, 4, 5, 6. Alright, so if I look at this, remember, what's anything divided by itself? Well, anything divided by itself is 1. So x divided by x is 1. X divided by x is 1, and x divided by x is 1. So I'm left with 1 up here on the top and 3 x's in the denominator, or 1 over x to the third power. So as you're getting into this rule, it might be easier for you to see the expanded form, all right, and understand where these things are going. Now another way I look at this, whoa, all right, another way I like to look at this is I say, okay, if I see x to the third over x to the 6th, I look at this and see, okay, my exponents are heavy in the denominator. They're heavier downstairs. So that means what I'm going to do is I'm going to subtract these down, and I'll have 1 over x to the third power. So just in that first example, you saw me do that 3 different ways. All right, 3 different ways. So you got to figure out which way made most sense to you, and then you can apply it that way every time. Let's see what another example might look like. Alright, let's say I had this, 3a to the 4th over 6a to the 9th. Alright, so again, our numbers, we handle those accordingly. 3 over 6 will simplify to 1/2. And then I need to take a moment and look at my a's. Now, if you want to do it the normal way, you subtract them. You subtract them up here to the top. Okay, well then you're going to be left with a to the negative 5th, and then you're like, uh-oh, I'm not allowed to have that. So you have to kick him downstairs, and we'd be left with 1 over 2a to the 5th power. All right, or again, another option, 3a to the 4th power over 6a, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 3 to the 9th power. All right, so again, we saw that that cancel or simplifies to 1/2. And then 1, 2, 3, 4 of those are going to be gone, and we're left with 5 a's on the bottom. So again, we end up at that 1 over 2a to the 5th power. All right, so again, I recognize this problem, I see it, and I'll say in this first step, I say, okay, well I'm bottom heavy on my exponent. So instead of subtracting the 9 up here, I would actually subtract the 4 down here, and then we'd end up here at this answer. So again, whichever way makes most sense to you. We're going to look at 3 more examples. All right, let's look at this next one. It is going to be 3a negative 3b 2 times 4a 2b negative 5. Okay, so let's just rock through this one like we normally would. Remember, when our rule is whenever we're multiplying things of the same base, we add their exponent. So I'm going to handle my 3 times 4 like normal. 3 times 4 is 12. All right, then I'm going to look at my a's. Okay, again, I add their exponent. So now I have a negative 3 and a positive 2. Negative 3 and a positive 2 is a negative 1. All right, and then I'll look here at my b's. 2b squared times b to the negative 5th, I add their exponents, and I end up with b to the negative 3rd. All right, so again, here in this step, I have both negative exponents, so both of these guys need to go downstairs. The 12 is allowed to stay up top, and a to the 1st, b to the 3rd, positive values, okay? So I think that's kind of the best way. Y'all are doing a really great job at these. I would just do it the normal way that you're used to, and now that you have these negatives, just kick them downstairs into the denominator. Here's our next example. X to the negative 2nd power raised to the 4th power. All right, so again, this is our power to a power rule. It tells us to multiply power to a power. We multiply our exponents. So this would end up becoming x to the negative 8th power, but I'm not allowed to have negative exponents, so he's got to be kicked downstairs, and I end up with 1 over x to the positive 8th power. All right, let's check out one last example. All right, I have 10a negative 2h3 over 8a 4h negative 6. All right, so this one you're like, oh my gosh, this looks terrible. It's going to be okay though. All right, so 10 over 8, if I plug that into my calculator and I wanted to simplify that, it would simplify to 5 over 4. So right now I'm at 5 over 4. Okay, now let's look at our a's. So if we're going to do the same standard where we are subtracting things to the top, this is negative 2 minus 4. Negative 2 minus 4 is a to the negative 6th power. All right, and let's say that we do the same thing here. This is 3 minus, but now it's 3 minus a negative 6. So look out for those double negatives. We end up with 3 plus 6. That will give me h to the 9th power, but again, I have a negative exponent. I got to take this one step further and kick out this a to the 6th downstairs. So I'd have 5h to the 9th over 4a to the 6th power. Okay, now there is one other way of solving this problem. I'm going to show it to you just in case it might suit your fancy a little bit better. So let's say I start here again. Over a 4h negative 6. Okay, so there's a way to flip this around in your first step. Okay, some of y'all might not like it, some of y'all might like it. So what if I say I'm going to move this whole h to the negative 6 up, and I'm going to move this guy down. All right, so that would look like 10. Now I have h to the 3rd, and now my h to the 6th is going to be positive. I'm going to have a to the 4th, and now I just kicked the a to the negative 2 downstairs, so now he's positive. And now it's just our product rule. We are multiplying these two things, and I can simplify from here. Again, the 10 over 8 will become 5 over 4. h3 times h6 is h to the 9th, and a4 times a2 is a to the 6th. Okay, so you end up at the same answer, so whichever way makes most sense to you is the way that you have to rock this, okay? Questions, comments, concerns, please come see your favorite Algebra 1 teacher.